So I'm going to do a quick little video on just a small set of the questions in the practice exam. I'm skipping around a little bit, so these will be some of the later ones. Eventually I'll have all of them up there, but I want to get the ones I think are most important out first. So if we go to practice exam A, and let's go to question 17. We have this information given to us that approximately 64% of people have a visual impairment and need lenses or surgery. Suppose we select 15 people at random. Well, we should start to think about someone either has a visual impairment or they don't. So we've got an example with a success failure. All right, so we should be thinking maybe binomial here. We know the probability that any one person would have, that's born has a visual impairment is 0.64. From that percent of 64%, it makes a probability of 0.64. And we're looking at 15 people, so that's going to become our number of trials, right? So our n is 15. Our probability of success, not minus, is equal to 0.64. Okay. If I want the expected number of individuals who have a visual impairment, I look at these values. Well, first of all, 15 here shouldn't make any sense, right? If the mean or expected number of people to have a visual impairment out of 15 was 15, it would have to be that the probability of having a visual impairment is 100%, right? And the reason we know this is we can actually go to our formula sheet. So we'll go over here. This set of questions relates to the binomial. Here's our binomial equations. Notice they're even kind of grouped for you. So the way you find the mean is simply take the number of trials times the probability of success. So here we've got n times p would be 15 times 0.64, which should be 9.6. Now another question I could ask you here is what's the variance? So that doesn't happen to be one of the questions in this, but if I did ask you for the variance, how would I have found that? Well, here it's as simple as once I identify I've got a binomial distribution example, here's my equations, here's the mean, here's the variance. So my variance is n times p times 1 minus p. Now I just plug my values in. My n is 15. My probability of success is 0.64 times 1 minus that probability of success. All right? And so if I do this, I should get, give me 1 second here, sorry, whoops. About 3, here I'll run the second decimal, so 3.46. If I then wanted the standard deviation, if I instead had asked you for that, there would be one more step, which is that you would have to take the square root of that variance you found, so the square root of 3.46. Okay? So those are all possible questions that I could ask you. We'll move to the next one that we actually have in this practice exam, which is what's the probability out of these 15 exactly 10 have a visual impairment. So this should be when we want the probability exactly one number of successes, we can use this probability mass function. So I'm just going to look at this function, and again, I'm going to write it out, plugging in the values for my example. My x here, right, I want the probability that x is equal to 10. So I now have my x is 10, my n is 15, my p, or my probability of success, is 0.64. I'm going to start typing out that equation, or writing out that equation in the context of my example. So n factorial would be 15 factorial divided by x factorial, my x is 10, times n minus x factorial. Multiply that by the probability of success, right, p to the x power, so 0.64 to the 10th power, and then multiply that by 1 minus that probability of success, so 1 minus 0.64 to the power of n minus x. Now if I wrote this out like this, I can enter this in my calculator, I should be okay, but we can simplify this, right? I know 15 minus 10 is 5. Maybe I can't quite do this, maybe it's not as easy to do in my head, but I can enter this in my calculator. So okay, 1 minus 0.64 would be what? 0.36. Okay, and then here I've got 15 minus 10. Again, I know that's 5. So now it's simple, just made it a little bit easier to deal with here. So we could enter this into our calculator. If we end up doing that, get and kind of see how long it takes to do these because I'm entering them into a calculator. I don't know these off the top of my head ahead of time. So I should get about 0.209 once I enter that into my calculator. Now I could have used Excel, and if I'm comfortable using Excel, that's great for this exam, but if I'm not, even if I use Excel, I might want to double check by trying to be able to do this with my calculator as well, because I'll show you what can go wrong. So here I can use that binom.dist function. It essentially is that probability mass function. You tell it n, p, and x. So the first thing is the number of successes, so we wanted 10. The second thing you tell it is the number of trials, 15. And the third thing you tell it is that probability of success, 0.64. Now the fourth thing we have to tell it is whether or not we want to make this cumulative. Well, we want exactly 10, so we don't want it to be cumulative, so we'll put a 0. Sure enough, we get the same answer that we found entering this into our calculator. But the problem is, if we can't remember the order of these arguments, and let's say I accidentally flip-flop the number of trials, number of successes, it'll look like it won't work, I'll get frustrated, I'll feel like I'm not going to be able to complete this exam. Or even if I made a mistake here and instead of telling it not to make it cumulative, I accidentally told it to be cumulative, well, now I get an answer that's not correct. All right? So if you are going to use Excel, make sure you're comfortable with those equations, and even if you're comfortable, I would double check it if you have time on the exam, entering it into your calculator. Okay, so the next thing we want is what's the probability, the next question, what's the probability that less than 14 people have a visual impairment? So here I want the probability that x is less than 14. Okay, so we said in class how would we find this? Well, I'd take every single number of successes that fits this criteria and add up all those probabilities. So the probability that x is what's the first thing that fits this criteria? 13, plus the probability x is equal to 12, plus the probability x is equal to 11, all the way down to 0. That's using that binomial equation way too many times, so there has to be an easier way to do this. So if I think about this as the probability of A, right? I know that the probability of A is equal to 1 minus the probability of its complement, right? And if I look at my formula sheet, kind of reminded of this rule up here. So here it's written as the probability of the complement is 1 minus the probability of the event. But if we rearrange this, subtracted this from both sides, added this to the other side, the probability of A is also equal to 1 minus the probability of its complement. So here, if my event A is x is less than 14, A complement is everything that doesn't fit that, so it would be that x is greater than or equal to 14. And I'm not inserting the symbol here, I'm kind of writing it the way that we do in Excel, and so this is, I couldn't insert the symbol, but it's greater than or equal to. Okay? So what's everything that fits this criteria? Well, that would be the probability x is equal to 14, plus the probability x is equal to 15, but because my number of trials stops at 15, that's where I have to stop, right? I can't see 16 out of 15. So I can find the probability that x is equal to 14, add to it the probability x is equal to 15, and then subtract it from 1. So what that would entail is using our probability mass function 2 times, right? Plugging in once that x is equal to 14, n is still 15, p is still 0.64, figuring out what that answer is. Then using that equation again for when x is equal to 15, now n and x are 15, the probability of success is 0.64, kind of finding both those probabilities, adding them up, and subtracting them from 1, right? So if I went ahead and did that, just kind of plugging those values in, it would look very similar to up here. I'll type this out for you here real quick. So 15 factorial, oh, it's bolded, but I guess we'll be okay. Divided by what, x? So the first x we have is 14 times n minus x factorial times the probability of success to the power of x times 1 minus the probability of success to the power of n minus x, right? So I'm just plugging my n, my x value, and my probability of success into this equation. Okay. I will then also need to find when x is 15 instead of 14. So I'll type that out. So we'll have this good to go. Right, and once I find those two probabilities, right, this is the probability that x is equal to 14. This is the probability that x is equal to 15. I'll add those up and subtract them from 1. So if I go ahead and do this, I'm going to cheat real quick and actually use Excel just so I don't have to type these out and can make this video a little bit shorter. So, oops. The probability that we see 14 out of, oh, I forgot to change this. I was gonna say that doesn't make sense. Right? We want the probably exactly 14. So I just, that's an example of how you can go wrong on Excel. So I'll put a 0 in there. Okay. I'm going to just copy this down because I didn't use any cell references. Change this one to 15. So I get what? About 0.01 and 0.001. Right? So if I were to kind of add these up and subtract them from 1, so 1 minus this plus this, oops, you get about 0.988, which sure enough is the answer I have here. Now on the exam, I'll make sure I have examples where like rounding wouldn't kind of, if I rounded this to the second decimal, I might think it's 0.99. I'll make sure that the numbers I give you on the exam, possible answers would be far enough away to where rounding wouldn't kind of lead you to the wrong answer, right? So we have 0.01 here, minus 0.001, and we get about 0.988, right? And kind of the trailing decimals here, I guess, is what makes it a bit smaller than one here. So this is the process for which you could solve this one using the complement rule in conjunction with that probability mass function for the binomial distribution. So the next kind of question that we want to work through will not be binomial, but I'll work through a quick Poisson one here at the end of this exam. So let's assume the number of people struck by lightning every year is approximately 3 people. What would be the probability that less than 2 people are struck by lightning this year? So first of all, we've got a time interval, right? Where was it? 1 year. We know the average rate over that year, so we should be using that Poisson distribution, or the probability mass function for the Poisson. Our lambda is the average rate, which we're told is 3. Our e is just this kind of natural number e. And then our x is going to be, well, we're not sure yet. It depends on this problem. So what are we looking for? We want the probability that x is less than 2. So this would be the probability that x is, we would take all the possible outcomes here. The very first possible outcome that fits this criteria is that x is equal to 1. Add to that the probability that x is equal to 0, and then 0 is as low as we can go. So I'm going to have to use this probability mass function 2 times, once where x is 1, once where x is 0. Okay? So the probability that x is equal to 1 will be lambda to the x. So my lambda here, I was told, is 3. So 3 to the x, well, here I'm looking at x is equal to 1. Okay? Times e to the negative lambda, so e to the negative 3. I'll then take that and divide it by x factorial. So my x is 1 factorial. Right? If I then want the probability that x is equal to 0, same kind of idea, except for now, my lambda is the same, it's still 3, but my x is now 0. So 3 to the 0 power times e to the negative lambda divided by x factorial. Right? So I go ahead, I enter this into my calculator. Oh, where's my e? There we go. E to the negative lambda. So this first one should get 0.149. Okay? And then the second one, oh, and I made a mistake here, sorry. I missed my to the power sign. Sorry about that. So this one I get about 0.049. Is that correct? Yep. So if I want the probability that less than 2 people, well, I have to add these together. So I'll take 0.149, add that to 0.049. Oh, I guess if I'm rounding these to the second decimal, we should get about, whoops. There we go. You actually should get 0.198. Once again, kind of it's because I rounded the third decimal here. If I kept it out to more decimals and then rounded my answer, I would have got 0.199. But I'll make sure on the exam I'm choosing numbers where kind of if you round whatever, I guess the rule of thumb for the exam should be whatever the answers are displayed in, you can round the intermediate calculations to that same value. And clearly, if you get 1.98, it's not going to be them giving you answers that, like where I have 0.199 and 0.198 as possible answers. Okay? So whatever the decimals are in here, when you're doing the intermediate calculations, round to that same number of decimals. The reason why I got a little bit off here is because I was actually doing everything on my calculator and not rounding anything. Okay? So that is a good example of Poisson distribution equation, and this kind of ends this little section of exam review.